Okay, so let's look at this next example, talking about a compound, diethylene glycol, that is used in antifreeze. So the question says, well, basically it's similar to what we have here in the first example, where they gave us the percentages of each element: 45.27% carbon, 9.50% hydrogen, and 45.23% oxygen by mass. And again, you're asked to determine the empirical formula. So let me get out of this again. Let me go here. Let me get rid of all this. Okay, so, all right. So again, I like to do it in a tabular fashion. Carbon here, hydrogen here, and oxygen at the top of the table. And again, we assume 100 grams of the substance, which means that the percentages will be also the masses in grams of each element for 100 grams of the compound. So the first row would be the masses, and I'm going to write for carbon 45.27 grams, for hydrogen 9.50 grams, for oxygen 45.23 grams. And we go through the steps as we did in the previous example. Second step is to find the moles. So in the case of carbon, that would be 0.27 grams multiplied by 1 mole over 12.01 grams. In the case of hydrogen, it's 9.50 grams multiplied by 1 mole over 1.008 grams. In the case of oxygen, it's 45.23 grams multiplied by 1 mole over 16.00 grams. And then we work out each of these. So here's my calculator. So starting with the carbon, 45.27 divided by 12.01. And according to my calculation, this works out to be equal to 3.769 moles. In the case of hydrogen, we divide 9.50 by 1.008. So in this case, you're going to end up with 9.42 moles. And then in the case of oxygen, we take 45.23 divided by 16, and this will give you, round off to 4 sig figs, 2.827 moles, all right? And then the next step is where, again, as we did in the previous example at this stage, we identify which of these have the lowest mole value, which would be this one right here, oxygen again, and we divide it right through by that number. So we're dividing by 2.827 moles. So in the case of carbon, that would be 3.769 moles divided by 2.827 moles. In the case of hydrogen, it's 9.42 moles divided by 2.827 moles. And then in the case of oxygen, that divided by itself will give you 1. So let's work out the ratio for the carbon and the hydrogen. So 3.769 divided by 2.827. Okay, so in this case here, when rounded off to 4 sig figs, you're going to get 1.333. And then in the case of hydrogen, 9.42 divided by 2.827. And here we're going to get 3.33. Okay, now this case here is a bit different from the first example that we worked, because you'll notice at this stage we have a recurring 3 after the decimal point here and here as well for hydrogen. So what we cannot do in this case is what we did the last time, which is that we rounded off in the last case, we round it off to the nearest integer. And the reason why we can't do that here is because the 1.33, for example, that number is too far from the nearest integer to just simply round off. And the same is true here for the 3.33. All right? However, or not however, but so what we're going to do instead is that we have to identify an integer that we multiply each of these numbers by so that it converts these numbers into an integer, right? And the hint lies in the fact that we have a recurring 3 after the decimal point. So what that tells me is that if I were to multiply right through by 3, right, then 1.33 times 3 gives you 3.999, 3.999, and the 3.33, when you multiply that by 3, that will give you 9.99, 9.99. So here we have two numbers now. Oh, by the way, you have to multiply this one by 3 as well. All right, you have to multiply right through by 3. So when you look at these two numbers now, you'll notice that they're very close to an integer, right? This is basically 4, and this is basically 10, all right? So therefore, in this case, the empirical formula will be equal to C4H10O3, all right? So that's basically how we would do this particular example, right? That's the answer, right? So just to recap, at this stage here, if you get numbers like these, which are very far from an integer, then what you need to do is identify an integer by which you multiply these numbers so that you convert those numbers to a number that is closer, much closer to an integer, all right? And then you go from there to establish what the empirical formula is, all right? Okay, we're going to stop here for this one.